Tonight's video is to help you prepare for tomorrow's test. The model of a tennis court is 6 inches wide and 13 inches long. An official tennis court is 78 feet long. What is the width of the official tennis court? Well, I know I'm talking about a drawing and an actual. So I set up my ratio drawing over actual. And the reason I focus in first on the lengths is because I know something about the length of the drawing and the length of the actual. So those are the first pieces of information I want to compare. I take something on the drawing and compare it to the same part on the actual. Then I break it down. Many ways to go about this, but I'm just going to figure out what 1 inch on the drawing would correspond to on that actual tennis court. So to get from 13 down to 1, 13 down to 1, I know it's an equivalent ratio. I have to either multiply or divide by something to get from 13 to 1. I'm going to divide the numerator by 13. Therefore, I have to divide the denominator by 13 to keep those ratios equivalent. 78 divided by 13 is actually 6. That tells me that this is my scale for my drawing. My scale is 1 inch on the drawing corresponds to 6 feet on the actual. Then I go back to my word problem and say, what are they looking for? Are they looking for more information about the drawing? Or are they looking for more information about the actual? So they want the width of the actual tennis court. It's important now. I'm like, oh, they're asking me for my final answer about the width. So now I'm going to focus on the width. I know the width of the model is 6 inches. Because I chose to put my inches in the numerator, I'll put my 6 in the numerator. Then I just set up an equivalent ratio. How do I get from 1 to 6? Oh, I multiply by 6. Always with equivalent ratios, you're choosing what do I multiply top and bottom by or what do I divide top and bottom by. If I'm going to multiply the numerator by 6, I multiply the denominator by 6. And I have just found out that that official tennis court is 36 feet wide. Please make sure you include your feet as your units on your final answer. Next question. It says the scale in a scale drawing Brittany made of her backyard is 1 inch is 8 feet. They're giving me the scale. A line on her drawing is 3.5 inches long. What does that represent in feet in her actual backyard? As soon as I know I'm talking about a scale drawing, I do drawing over actual. And they gave me the scale. They tell me 1 inch in the drawing corresponds to 8 feet in that actual backyard. What other information do they give me? Hey, they tell me they're giving me a line that's 3.5 inches long on the drawing. And they just want to know in her actual backyard, how many feet long is that? So I say, okay, I know about my numerators. 1 inch, I need to get that up to 3.5 inches. I'll multiply my numerator by 3.5. That means I need to multiply my denominator by 3.5. So I take my 8 times 3.5. That's 8 times 3 times 2 is 6 and 1 is 7 halves. 8 is the same as 8 over 1. I multiply straight across the top, straight across the bottom. 8 times 7 is 56. 2 times 1 is 2. 56, that fraction bar means to divide. 56 divided by 2 is 28. Hopefully you're using your calculator or pausing the video and doing the calculations longhand. So that tells me 3.5 inches on our drawing corresponds to 28 actual feet in our backyard. Please make sure you include your units of feet on your final answer. Let's try another one. An Olympic-sized swimming pool is shown. Troy is building a pool that is proportional to that Olympic-sized swimming pool. The width of his pool is 500 centimeters. Find the length of Troy's pool. So he's making a little model or a little scale drawing. So we're doing drawing over actual. Let's take a look. in his drawing is in centimeters. The actual Olympic-sized swimming pool is in meters. So I focus in and I say, what do I know about? What parts correspond? Oh, I know 500 centimeters corresponds to 25 meters. So I literally fill in 500 centimeters is 25 meters. Then I break it down and I try to find out per one. As I look at this, I see, oh, you know what would be easiest to find per 1 meter? 25 divided by 25 is 1. 500 divided by 25, because I have to do the same to the numerator and denominator, is 20 centimeters. Lots of ways to go about this. I chose to divide top and bottom by 25, so I didn't have to deal with any sort of decimals. So I know 20 centimeters is 1 meter. 20 centimeters on my drawing corresponds to 1 meter on my actual pool. So I'm going to use that scale. That's my scale. I've just found my scale. Drawing over actual. 20 centimeters corresponds to 1 meter on the actual. Then I'm like, I know the actual length of my pool, and they want to know the length of Troy's mini pool. Oh, I could totally just compare lengths. Again, centimeters to meters. They tell me the actual pool is 50 meters. They give me that information. I'm going to use that information to help me find out how many centimeters Troy's little mini pool will be. Well, how do I get from 1 to 50? I focus on my denominators. I know about my denominators. 1 times 50 is 50. If I'm going to multiply the denominator by 50, I multiply my numerator by 50. 20 times 50 is actually 1,000 centimeters. This is awesome. I know Troy's pool is 1,000 centimeters long. Hopefully you're noticing there's a pattern here. Anytime I'm dealing with scale drawing, in my mind, I put drawing over actual. I then make sure I include all my units. I find a scale, and I use that scale to help me find the missing piece. Let's take a look at the next one. Mr. Taylor made a scale drawing of his backyard. Find the length of Mr. Taylor's actual lawn. The length of his actual lawn. So I focus in on the picture. I'm like, yay, they give me a scale. As soon as I know a scale, I can do my drawing over my actual. I know 1 inch on the drawing corresponds to 3.5 feet on the actual. I'm going to be looking for how many feet for the actual length of his backyard, which means I need to know how many inches, the length of his lawn. So I need to know how many inches the length of his lawn is on the scale drawing. So I just focus here. I say, okay, I want the length of his lawn. They don't seem to give me the length of his lawn, but they give me the length of the entire backyard, and they give me the length of the paved driveway. If I take the length of the entire backyard and I simply subtract off the length of the driveway, I'll be left with the length of his lawn. So that's what I'm going to do. 11 minus 4.1 is 6.9. So I know the length of his lawn must be 6.9 inches. And I just create equivalent ratios. How do I get from 1 to 6.9? Oh, I multiply by 6.9. If I'm going to multiply the numerator by 6.9, I multiply the denominator by 6.9. You go ahead and you use your calculator, or you do this longhand. You'll come up with 24.15 feet. That tells me the length of his lawn is 24.15 feet. Excellent. Wonder if they're going to ask me about the width of his lawn. We just realized the length, and now they want to know the width of the actual lawn. Again, they give us the scale. As soon as I know I'm given a scale, I can do drawing over actual. 1 inch in the drawing is 3.5 feet in the actual. They must give me information about how many inches long it is in the drawing for the width if they're asking me to find the width of the actual in feet. So now I take a look at my width. I go, okay, I need to know the width of my lawn. Well, here's some good news. They give me the entire length of the backyard as being 8 inches. And they give me the width of his vegetable garden right here as being 3.3 inches. So guess what I do? I just subtract the entire length, or I'm sorry, the entire width by 3.3, and that will give me the width of the lawn. So I do 8 minus 3.3, and that actually turns out to be 4.7. So I know the width of his lawn in the drawing is 4.7 inches. So I'm like, oh, inches went on top, drawing went on top, 4.7 inches goes on top. How do I get from 1 inch to 4.7 inch? Hey, I multiply the top by 4.7. I'm going to multiply the top by 4.7. I multiply the denominator also by 4.7. If you do 3.5 times 4.7, you will come up with 3.5 times 4.7 on my calculator. I come up with 16.45 feet. I have just figured out the width of the actual backyard, and hopefully you're noticing my process is the same every time. I do drawing over actual. I either am given a scale or I find the scale. I then use that scale to figure out the missing piece. The last piece I want to look at is the perimeter of Mr. Taylor's actual lawn. I know this is the drawing, but I'm just going to label it as though it was the actual. So the width of our actual we just found to be 16.45 feet. The width on this side we know must also be 16.45 feet. The length here, a few slides ago, we found to be 24.15 feet. So the length here at the bottom of the lawn is also 24.15 feet. To find perimeter, we simply add up all the sides. Add up all sides. So what we're going to do is just take 24.15 plus 16.45 plus 24.15 plus 16.45. We're going to find out that that's 81.2 feet. Use a calculator or go ahead and work longhand. All I did was go around the lawn, adding up all of the feet, and I got 81.2 feet for the perimeter. If you watch this video, please write on the top of tomorrow's test, I watched this video, and you will receive a bonus point. Have a good night.